So hello everyone, this is Akshay here, and today we're gonna cover a question, a very standard question on level auto traversal, but the only changes here is that we need to cover in a spiral form. So before starting ahead, if you're new to this channel, please like, share, and subscribe so that you can learn, maintain, and grow a streak together, and hit the bell icon to get the regular updates. So we have been given a given tree, a binary tree, and we need to do a spiral level auto traversal. So what does that mean? Let us see the input and output first. So suppose this is the tree given to you. So in the level auto traversal, we already knew. I have made a video and I've uploaded in my playlist. It must be showing up here now. You can go and watch that video first. In the level order, we need to go level wise and we need to cover from the direction left to right. So first 10 would be printed, then 20, 30, and then 40, 50, and 60. So this would be the answer if you'd have done the standard level order traversal. But here we need to cover in a spiral form, right? So first 10. First, we need to do in left to right, and then again we move from right to left, and then again we need to move from left to right, and keep on doing it until the end of the tree. So first 10 is printed, and then 30, 20, and then 40, 50, and 60, as you can see, right? The direction changes for each and every level. Similarly, for 1, 2, and 3, first 1 will be printed, that is from left to right, and then right to left, 3 and 2 would be printed. How we can tackle this question? So in the level order transfer, what we do that we made a queue, right? Let me give you a very quick overcap. We make a queue, and then we push the root node, and then we pop the peak. We pop the first element from the remove the first element from the queue, and then we push its children, right? And we add the popped element, that is a remove element, in the answer, and we push 20 and 30. Again we keep on removing the first element from the queue and keep on adding its children until the queue is empty. So what we did then, we processed 20, added the 20, and we see if the children of 20 are there or not. So it's 40 and 50. So we add 40 and 50 into our queue. Then again we keep on processing it. So we remove 30 now, and the 30 children is 60. So we add 60 in the queue now, and then we remove 40. So 40 has no children, so we'll not add nothing. Then 50 has no children, then we add nothing. Similarly, the last node that is to be processed is 60, and it has no children. Now you can see the queue is empty, and you have got your level auto traversal, right? So definitely watch this video first in my current playlist, and you will get a very good idea regarding the code as well as the dry run as well. So what can we do here now to convert this level auto traversal and do the traversal in a spiral form? So definitely, if we push the children like blindly, like push first the left children and the right children, definitely the 20 and 30 would get pushed. But I do not want that, right? I want it to be in some other order. So instead what we can do is that we can make a two stack. So let's say we name it stack S1, and let's say we name it as stack S2, right? So in S1, let us push the first node, that is the root node here, and then we will process this stack first, right? So S1 is empty or not. So we will see, we'll keep on popping out the nodes from the S1. So 10 will be removed, add your 10, add the 10 as your answer, and push its children into it another stack, that is S2. So in S2, we need to push 30 and 20, 30 and 20. So that means while you are adding your children in S2, you need to maintain one order, right? You have to push the right children first, push right child, and then you need to push left child, right? And am I saying it in the reverse order? Yes, I said it in reverse order. So what we want in the second order to be printed is 30 first and 20 at the last, right? So stack follows the LIFO order. So we will push 20 first and 30 at the end, right? So that means when we pop the elements from this stack, 30 would be removed first, and that will give our continuation to an answer. So that means when we are adding the elements into our S2, so what we need to do is that we need to push the left child first, push left first, and then push right, when we are falling in order of S2. So okay, so the 10 was pushed out, so let me write the current answer here. Then 30 would be pulled out, and whenever you are removing the top element from the S2, that means you will be adding its children in S1, right? So let us follow the continuation. So 30 is added in your answer, and then 30 children is what? 60, right? So 60 would be added in your stack, correct? Then next 20 would be processed, 20 would be removed from S1, and then its children would be added. So what we do now, do we add 50 first, the right child first, or left child first? See, what we want in our answer, we want 40 first, right? So that means 40, that means the other child need to go in the stack first, that is 50 need to go first, and then we need to push the 40, right? So which order we are following? If we are pushing the elements in S1, we are pushing the right child first, right? So let us just write here the pseudocode as well, that we need to push right, and then we need to push left if we are pushing it to an S1 stack, right? Okay, then again we will again pop out each and every element from this S1 stack. So we will remove 40 and 40 would be added in an answer. 40 has no children, so nothing would be pushed in S2. Again, 50 has no children, nothing would be pushed in S2. And similarly for 60. And as you can see that this is our required answer and we have achieved it using two stack method, right? Using an auxiliary space. So, yep. I think that would serve our purpose. So what is the time complexity and space complexity for this code? Time complexity is again we are visiting each and every node once, so it will be O of n. Space complexity, we are using a two stack, but eventually we are just pushing each and every node in our auxiliary stack, so it will be O of n again. Correct? Now please pause this video and try to code this approach by yourself, and then you will understand how the code flow is there. One more hint I want to give you while you are writing the code: when would be your stop condition, right? So we will be stopping. In this case, you have seen that S2 was empty and then we stop it, right? But let's say one more level was given here for this 40 and 50, 60, 70 and 80 would be present. So definitely S2 will have some elements, and in that case S1 would be the empty stack, right? So that means you need to write a while loop, the first and foremost while loop, that either of the stack, if it is not empty, you need to continue the process, right? Please pause this video now and try to code this approach, and then we'll see the code in the code editor. Okay, so that's the code here. Let me give you a code walkthrough very quickly. So since the return type is the array list, so we have made an array list to add the answer in this list particularly. And thus, if the root is empty, like if the tree has no particular nodes and the root is pointing to null, then definitely there will be no particular answer, and we will return the empty array list, right? Similarly, for if only root is existing and its left and right shell is not existing, then definitely add the root data and return the arrays, right? Great. Then let's say now the tree has more than two levels, two or more than two levels. So we will use a two stack, and then we are in S1, we are pushing the root method, and we already discussed why this while loop is necessary. We need to check for either of the stack is should be not empty, else we will continue the process, right? So the process is that we need to check for the S1 first, that if it is not empty, you need to pop the elements from the stack, you need to add that element into your array list, and you need to follow the order of first pushing the right children and then pushing the left children. Since why this is done, because the spiral traversal was asked to do first left to right and then right to left. If the order was different, if the order would have been a little different, let's say from the first level you'd have to do right to left and then you need to go from left to right, then definitely this order would also have been changed, right? What we discussed in the dry run, instead of pushing left and right in S2, we'd be pushing right left in S2 and left first and right afterwards in S1. I hope that is making sense to you guys. So let us continue with the code walkthrough. So definitely in the S2 we will push the right child first and then the left one. Once you have seen that the stack one is empty, then definitely there will be some next, like for this current level the next level children will be pushed in S2, and similarly if the S2 is empty, then that means the next level children would be pushed in S1. I hope that is making sense. And again, we have already discussed what we need to follow the order in the stack 2, and that's it. We are adding the answer in our this array list named as AL, and that's it. We need to just return the return AL, and that's it. I guess we will get the answer. So let us hit the compilation button. We have already discussed the time complexity as well. Let us see if the case is passed successfully. So definitely it has passed. So if I hit the submit button, it should definitely get submitted. And before just making sure, let us see the constraint as well. So the constraint is 10 per 5, and definitely our solution is O of n, right, which is less than 10 per 8, and this solution should get submitted, and that is what we can see. So again, for this problem also I have not scored any marks. So as you can see, I have already done this question. My last submission was in 2021, I guess. Yep, 2021. So okay, great. So I hope you guys are enjoying the video. You guys are taking the help from the intuitive approach of our problem solving session. So yep, so keep learning, keep growing. Bye bye, and take care guys till we meet next time in our next video. Bye bye.